What the heck is molybdenum? I'm Meredith. I'm a dietitian, but I'm probably not your dietitian. So please talk with your own provider before you make any changes to your diet, supplements, or medications. This is just information. It's not meant to diagnose or treat a condition. And yeah, you need to talk with your own provider. But I wanted to share a little bit about molybdenum because there's so many questions that are asked in our support group, such as how much molybdenum in which form. And so that's what this presentation is about. So let me get my face out of the presentation so that you can see the full slide. So what is molybdenum? It's a trace mineral. It's required for making molybdenum cofactor, which is MoCo. MoCo is used in only 5 enzymes in the human body. MoCo is not used in the enzyme FAD synthase. So what FAD synthase has is an MPT-like domain. The keyword there is like. It looks a lot like MPT, but MPT is not even molybdenum. MPT is basically like the shell that molybdenum is put in to make molybdenum cofactor. And then it's actually part of the FAD synthase enzyme. So whenever the body codes for FAD synthase, the amino acids that are in there, they look like MPT when they line them up and you make the actual FAD synthase enzyme. So FAD synthase also has a PAPS domain that looks like PAPS, and PAPS is something that we make out of sulfate that's used as a cofactor for sulfur transferase enzymes, which are phase 2 detox enzymes. But again, it looks like it, but it's not actually having PAPS added to it as a cofactor. It's just part of the entire coded enzyme that it happens to have these 2 domains. So many times people have told me, but I was told that when I took molybdenum, it fixed my FAD deficiency because suddenly I no longer had high succinate levels on my organic acid test. And also, I no longer had any problems with my short chain fatty acid metabolism. Well, something funny is that sulfite, if you don't have enough molybdenum cofactor, then sulfite itself will inhibit succinate dehydrogenase. And so that will make you look like you have a FAD deficiency when in actuality your struggle is very much with sulfite. And then sulfite can also bind to this N5 position on riboflavin. And so it could be causing problems with your ability to do short chain fatty acid metabolism as well. There's this thing called FTE. So again, it's probably not that molybdenum is needed for FAD synthase. It's just that the what am I trying to say? The resolution of your sulfite toxicity is improving your metabolism in areas that are related to FAD. So that being said, these are all the sources, and you can just look at the screen for this, of molybdenum content. And over here, I put the oxalate content because a lot of times people who are struggling with sulfite metabolism very much struggle with oxalate. And the reason being is because sulfite will cause so much oxidative stress that the mitochondria is shut down. And then NAD recycling ends up occurring in the cytosol at lactate dehydrogenase, and oxalate will inhibit lactate dehydrogenase. And so then it can cause some severe issues with energy metabolism and fatigue if you have mitochondrial problems and are consuming oxalate and absorbing a lot of it. So probably the best source of molybdenum from our diet would be either lentils or black beans. And some of these things might contain salicylates too, and that's a whole other thing that people can struggle with when their metabolism is not working well. So a lot of times people will resort to a supplement instead. So molybdenum, the RDA, is 45 micrograms. And so you can see just eating 1 cup of black beans is 130 micrograms. So you wouldn't even need to eat that many black beans. What would you need to eat? Like divided by like maybe not even half a cup, maybe a quarter cup to meet the RDA. So in our family, one of our kids became allergic to beans and we all cut them out. And I think that was a huge contributor to our downward spiral because we weren't eating beans as much. We used to make red beans and we used to eat refried beans all the time, but this one of our children became allergic, and so we all cut it out. And I think that led to having a molybdenum deficiency. So how much molybdenum? Again, we need about 45 micrograms as an adult, and then kids need much smaller amounts, so it's a little bit less. The forms of molybdenum, there's molybdenum glycinate chelate, there's sodium molybdate, ammonium molybdate, molybdenum citrate, molybdenum chloride, and then there's mozyme. And there is another whisper down the lane comment that mozyme is MoCo. No, it is not. Mozyme isn't MoCo. It just is molybdenum with superoxide dismutase added to the tablet. So I guess in theory, the SOD might be an attempt to bind to copper, because if you have molybdenum in the presence of sulfur, and then you also have copper, that could interfere with the absorption of those two things. So I'm not really sure. I am sure that just taking mozyme doesn't solve everyone's problem, because you still have to make the shell for adding molybdenum cofactor to it to add molybdenum to it to make MoCo. So again, next presentation on that. So ammonium molybdate is what's used to make tetrathiomolybdate, which and so I'm going to show you the next slide. But basically, I don't recommend ammonium molybdate for this reason, because if you have SIBO and you happen to have hydrogen sulfide producing bacteria, then you're at risk for making your own tetrathiomolybdate. Now, this is really seen in animals that chew the cud, ruminants. So, but in theory, it could happen in humans. It's really hard to test for hydrogen sulfide producing bacteria in the small intestine. There's not really a good test for it. And so this is just based on theory whenever people believe that they might have that type of bacteria backing up into their small intestine. So this slide is about the virgin sodium molybdate. They have found in vitro studies. This is in vitro means that it's not done in a live model. It's just a cell study. But they found that sodium molybdate can inhibit sulfate reduction in the sulfur-producing bacteria that are listed here. And when these bacteria stop using sulfate to make hydrogen sulfide, they switch to using sulfite and thiosulfate. So whether or not that's applicable to our in vivo models, I'm unsure, because we're not doing high doses of sodium molybdate. But could it give you a sudden decrease in hydrogen sulfide production in the gut? Because if these bacteria are using sulfite or thiosulfate, we're not going to have that readily available in our gut. It's going to be inside a cell. I do not believe we efflux sulfite and thiosulfate into the small intestine. So these particular sulfur metabolizing bacteria would have a temporary reduction in hydrogen sulfide production. And so again, this was in vitro. So whether or not it's helping people, who knows? But some people say that sodium molybdate helped them so much. So maybe that's why. And this particular bacteria, desulfovibrio, is actually thought to cause all of these health issues over here. So myocardial infarction, cancer, liver disease, chronic kidney disease, autoimmune disease, periodontitis, metabolic syndrome, IBS and IBD, bacteremia, and autism, as well as Parkinson's disease. So perhaps if you have any of these conditions and you suspect that you have hydrogen sulfide producing bacteria in your gut, or if you're in your colon, you actually have higher levels of this disulfovibrio bacteria, maybe sodium molybdate is the better choice for you when you're choosing supplements. So the other thing to know is that these bacteria use nitrate as an energy source, and they produce ammonium and nitrite, but only in the absence of sulfate. So if you do have this bacteria in the gut, having a very low sulfate diet could actually switch your disulfovibrio bacteria into a nitrate metabolizing phenotype, and then that would increase ammonia production. So consuming nitrate will actually shift the gut microbiome away from sulfate producers towards nitrate reducing bacteria also, such as E. coli. So this would be where if you're struggling a whole lot, you might get a GI map, and so you can decide what would be the best thing for you to consume from a dietary standpoint. If you have this particular E. coli 0157H7, it actually causes hemolytic uremia, and basically your red blood cells will be breaking down really fast, and that can release cyanide when you start to metabolize the heme with heme oxygenase. So it would be a good idea if you're really struggling metabolically to get a GI map to see if you have either E. coli or this disulfovibrio bacteria. And I feel like that's just a side note. So sorry, I kind of rambled off. But again, what would you do if you have this disulfovibrio bacteria? You still really do need molybdenum. So sodium molybdate would probably be the one that you would go for if you're going to supplement. And then I would avoid consuming nitrates in excess because they can feed the disulfovibrio bacteria. And then also if you have that particular strain of E. coli, it could cause some serious damage to your health. Okay, moving on. And here's this, I'll add this link to the show notes so you can read this article about disulfovibrio in the gut, the enemy within. It's really interesting. Okay, functional compensation of the gut microbiome. So this is something that is out there. There's a lot of thoughts that maybe we grow the sulfur bacteria to make up for sulfate, that we need more sulfate, but that doesn't make sense because disulfovibrio leads to more hydrogen sulfide, and hydrogen sulfide leads to more sulfite. And so, I mean, in theory, it could be that you're not very good at producing your own hydrogen sulfide from your transsulfuration pathway, and maybe that's why you grew the disulfovibrio bacteria. But it's also possible that you're bad at making SAM, which is how it's a methyl donor that we use in our body for various reactions. So it's S-adenosyl methionine. So disulfovibrio leads to elevated systemic SAM concentrations. So a theory, by the way, just a theory, what if when you are really bad at making your own SAM, you grow this particular bacteria to make up for it? But the negative side effect of excess hydrogen sulfide production leads to the inflammation in your gut. So yeah, maybe that would be something to look at. Is my sulfur producing bacteria a consequence of not being very good at SAM production? And here's something very interesting is the methionine salvage pathway is very sensitive, I think, to sulfite toxicity because sulfite can cause a functional B12 deficiency. B12 is needed for the production or for the salvage of homocysteine to make methionine and then SAM. So that could be part of the issue. And then sulfite creates a whole lot of oxidative stress, which would increase the levels of hydrogen peroxide, which can lead to the inability to convert methionine to SAM. So again, it's like this vicious cycle that we potentially have going on in our bodies. And I know you guys feel that. You feel like you're in a paradox. Well, Jenny and I at first called it a trap, but it sounds so horrible and we want to give hope. So you're stuck in this weird paradox where you just can't get out, right? So, this could be it. This could be the reason why. And this study was actually done on cancer cells because they were trying to figure out why people were being resistant to chemotherapy. And it was the presence of this disulfo vibrio bacteria in their gut made them have more acetylmethionine. And that kept the chemo from working because it contributed to the total methylation that they were trying to prevent. Pretty interesting. So there's not just the disulfovibrio bacteria that make hydrogen sulfide, although they do that from sulfate, sulfite, and cysteine. But here's a list of other bacteria that can be found in the gut microbiome that can contribute to hydrogen sulfide production. So you can pause and read all these different types of bacteria that could be problematic. And the reason why they could be problematic is now on the next slide. So, what if you do have these particular hydrogen sulfide producing bacteria in your small intestine? You could do a GI map, but a GI map is not going to catch what you have in your small intestine. A GI map is a PCR test that looks at the bacterial DNA to see which type of bacteria you have in your stool, but it's not going to catch what you have in your small intestine. So if you think, though, that you might have a high hydrogen sulfide state, then that could potentially cause molybdenum malabsorption or copper chelation. So let me explain how. So right here, so over here we have molybdenum, okay? And then this is a version of molybdenum called molybdate. And you can see it's MoO4 2 minus, and sulfate is SO4 2 minus. Molybdate is considered a sulfate analog because it has the same tetrahedral geometry and charge properties. So they look similar, and really high molybdate in the gut could potentially impair sulfate absorption. So that's something to consider. Over here we have sulfate, and then this says S amino acids. So sulfur containing amino acids like cysteine and methionine can provide sulfur that can take your molybdenum, your molybdate that you make. So we actually convert all of our molybdenum into molybdate in the gut, and that molybdate can have sulfur added to it, and it can make these intermediates, and eventually you end up with tetrathiomolybdate. Okay, so tetrathiomolybdate can bind to the copper in the gut, and then that would actually be chelated and you would not absorb your copper. So if you have chronically low copper levels and you suspect that you have hydrogen sulfide producing bacteria in your small intestine, that could be the way that you're struggling with copper absorption. So in theory, what you would do is you would try to take your copper or eat your copper foods away from foods that have molybdenum, which is kind of hard because some of the copper foods might contain molybdenum. So it'll take a little bit of working out to figure out what's going on with that. But also this tetrathiomolybdate, they've seen this in ruminants, animals that chew their cud, and then also in rat studies, if they give this tetrathiomolybdate, then it can actually bind to copper in the blood, and it can induce a copper deficiency. But if you just absorb molybdate from your diet without it being modified into these particular other forms of molybdate that have sulfur added to them, you are not going to chelate the copper in your body. Molybdenum alone cannot chelate copper. It has to have these sulfur groups added to it. So, so again, you have to form this tetrathiomolybdate to be able to chelate the copper. Okay. Okay, so moving on. So molybdate can actually, like I showed in the previous slide, it can inhibit disulfovibrio bacteria producing hydrogen sulfide from sulfate, but it's not inhibiting hydrogen sulfide production from methionine or cysteine. So even if you were to take very high doses of molybdate to try to inhibit your disulfovibrio bacteria from producing hydrogen sulfide, you're still going to end up having some of your dietary amino acids producing hydrogen sulfide. So there's a big struggle. There's a big struggle for people who potentially have hydrogen sulfide producing bacteria in their gut, because you could, in theory, develop a copper deficiency from this. So what are dietary sulfites? What are they found in? They're found in cruciferous vegetables like broccoli and cauliflower and cabbage. They're found in garlic and onions, dried fruits, and some drinking water has higher levels of sulfate in it. So one of my family members grew up in Louisiana, and Louisiana has a very high sulfur content in their water. And I think that was a big contributor to some of their current health problems. So you could end up encouraging the growth of these disulfovibrio bacteria if you have a very high sulfur content in your drinking water. So excess tetrathiomolybdate can chelate copper. That's what we need to take from this. One thing that I was doing is eating an apple at the same time that I was taking my molybdenum, and it actually seems to work. And I've noticed that if I eat an apple, I don't have as much sulfur smell to my bacteria than if I don't eat an apple. And Jenny says that the apples that are the lowest in salicylate are the Red Delicious apples, and then you can peel them if you're struggling with salicylate intolerance, because apples do have salicylate, but it's mostly in their peel. So what an apple would do is provide pectin, and then in theory, and this actually comes from Chris Masterjohn, his sulfur protocol, he talks about how you can eat an apple to decrease the hydrogen sulfide production in the gut by bacteria. And so I was like, hey, I'm going to combine it with molybdenum, and his goal is to reduce the total amount of hydrogen sulfide between the gut producing it and people producing it, because hydrogen sulfide in excess causes sulfite toxicity. So I kind of just took the apple thing and I was like, that's really cool. Nice find, Chris. And then I've been combining my molybdenum supplement with my apple to try to stop the bacteria from making too much hydrogen sulfide while my molybdenum is there in my gut. All right. So this is from Gene Cards, and there's an actual molybdate anion transporter. So it's very rare that other minerals are going to compete with molybdate for absorption, because it has its own designated transporter to get into the human body. So that's good to know. So how much molybdate or molybdenum is safe? Well, the upper level intake for molybdate is set at 2,000 micrograms for an adult. And you can see for children, it's a little bit smaller. So under the age of 9, the upper level intake is 600 micrograms. But there is a recent study that is a bit concerning to me. How much molybdenum is safe long term? Now, if you're actually supplementing molybdenum at high dose to try to reverse sulfite toxicity issues, will it cause any damage if you continue for a very long time? Well, this study in China showed that there's nephrotoxicity from molybdenum exposure, and it can trigger hepatotoxicity and pulmonary toxicity. So what they're saying is that first the kidneys go, and then the liver, and then the lungs. And so they looked at what would be the maximum exposure of molybdenum per day, and it would be about 0.87 micrograms per kilogram per day. So for an adult, that's just a little bit above the RDA. It's about 55 micrograms for the average adult. And our supplements are anywhere from 50, it could be the RDA, or Mozyme Forte is 150 micrograms. And then Seeking Health uses 400 micrograms of molybdate. And people are doing even higher doses than that. So the current exposure guideline is 50 to 30 micrograms per kilogram per day, which is the UL, right? It's the UL of the 2000 micrograms. But they're finding that the lower doses that are closer to the RDA are causing toxicity in these people who live in China. And the study was well done. It even accounted for heavy metals as the toxicity, and they found that it wasn't that. So I'll put a link to this study in the show notes. And it's something to consider. So what would you do? Well, if you're concerned, you could have a comprehensive metabolic panel to calculate your estimated glomerular filtrate rate, and then also ask your doctor to check cystatin C. Because if you have kidney disease, your cystatin C will be high and your estimated glomerular filtrate rate will be lower. And the thing is, push for the cystatin C to check your kidney function, because EGFR can vary based on your BUN and your creatinine levels, and those can be changed by muscle mass and how much protein you eat. So ask for the cystatin C for sure. But if you already have a low estimated glomerular filtrate rate, you would want to ask for the cystatin C to be done. And if kidney disease runs in your family, you should probably consider not doing high dose supplementation with molybdenum for too long. Remember, it's not just molybdenum that is needed to make molybdenum cofactor. There's multiple other nutrients involved. And what you want to do in your body is to harness that molybdenum inside the shell called MPT to make MoCo. You don't want your molybdenum to be floating around in your body, potentially causing kidney health issues, which could lead to liver and lung issues, according to this study, which, yeah, I think it's a good study to think about. So I was looking up why molybdenum would make a person's heart race, because I have a friend who sent me that message that they can't take molybdenum. Every time they take it, it makes their heart race. And having your heart race continuously will keep you from sleeping. It makes you have anxiety, and anxiety would help you to produce more catecholamines, and catecholamines will make your heart race. And also they attract unhealthy gut bacteria to grow in your gut. So not a good situation for your heart to be racing. But why would it be doing this? Well, this is an in vitro study showing that molybdate can increase adenylate cyclase activity. And I know everyone's going to say, it's in vitro. That doesn't mean that it's happening in humans. But we all know that people who have mitochondrial dysfunction, they're sensitive. We're sensitive. We feel our metabolism. We can eat something and feel the changes happening in our bodies, like a sinking feeling in the brain, right? And so being more sensitive doesn't mean that you have a psychological problem. It means you have a mitochondrial problem. So it's quite possible, I think, that molybdate could be the source of activation of adenylate cyclase. And adenylate cyclase causes a cascade that leads to myocardial contraction. So I was looking at what would be the best solution if molybdenum supplements were making someone's heart race. And I think figuring out if someone has a magnesium deficiency and then giving magnesium, and actually magnesium would be helpful in general if your heart is racing, because it's a known inhibitor of adenylate cyclase. And it isn't problematic like sodium and potassium, even though if you have low sodium and potassium levels, you definitely should get those up because they can inhibit adenylate cyclase activity. But also, though, sodium and potassium can stimulate this activity if you have fluoride in your blood or catecholamines. So magnesium is the safer solution. And then Other inhibitors of adenylate cyclase are manganese and chloride, but chloride is typically problematic for people who are struggling with sulfur metabolism. I've noticed a bunch of people having hyperchloremic non-ionic acidosis and being very sensitive to chloride, where if they consume something with chloride in it, it gives them a skull-based headache, which might be hyperchloremia, can cause intracranial hypertension. So it would be something that sodium chloride, like eating more salt, I probably wouldn't choose that if you're having tachycardia. Of course, consult with your own practitioner because I have no idea what's going on in your body. This is just me talking about things. So then manganese, that can be problematic. You can get manganese toxicity. And I think that people who are struggling with sulfite metabolism are struggling with getting enough vitamin D to their gut. And if you don't have enough 125 OHD in your gut, then you actually don't induce the gene transcription for the manganese exporter, this thing that will remove excess manganese from your enterocyte. So I would consider that. Again, you may be manganese deficient. I don't want to take your manganese supplement away from you. You're an individual. Talk with your own provider. And then I would avoid bicarbonate within a few hours of taking molybdenum because bicarbonate can actually activate adenylate cyclase as well. And in general, I don't recommend chronic bicarbonate use because you are altering your pH and you can swing into alkalosis pretty easily. The max I usually recommend for using bicarbonate is a quarter to a half of a teaspoon. And even when I see people in severe metabolic acidosis and I calculate their bicarb deficit, it's usually not over what would be a quarter to a half of a teaspoon of bicarbonate. Another possible side effect of increasing molybdenum could be an oxalate dump. If molybdenum is the only factor preventing you from making enough MoCo to be able to support sulfite oxidase and the metabolism of sulfite, as soon as you increase your molybdenum, you might notice that you have an oxalate dump. And this is something that Jenny noticed. So between the two of us, we worked pretty hard on figuring out what was going on with oxalate dumping. And you can watch the video Sulfite and Thiosulfate Alter the Metabolic Processing of Oxalate. And it's pretty interesting. I share my daughter's 24-hour urine test and her organic acid test. And I will tell you more about these pathways and have a nice diagram as well to support it that I drew out. And it has a lot of information as always. So funny story, and I shared this with my friend Sergey, that when I was in 9th grade, I had a coach. He was my softball coach, Coach Snyder, but he was also my biology teacher for honors biology. And we had to do this experiment, and it was protozoan succession. And so we filled a fish tank, and then we went out into like behind the school and went to this little stream, and we got some water and we inoculated the fish tank with the water. And then over the course of the semester, every week we took some out and we looked at it under slides and drew pictures of the creatures that were there. And so then we had to write a paper at the end. And so I had so many drawings, and I looked up all of these microorganisms and found information on each one. And I turned in my paper, and it was over 100 pages. And so he gave it back to me, and he gave me a 95, which was really kind of him because he said, "You did not follow the instructions. The instructions were 10 pages. This is 100 pages." And he said, "I do not think you're going to be a softball player." So that's pretty funny. I do have a really hard time not putting too much information down, but that's just how my brain works. I like to know everything. So that's why I didn't add all the sulfite stuff to this video. I felt like it would be really long, so it's a separate video. So the last thing that can go kind of crazy when you start your molybdenum is you could end up having gout. And I would think that this would be transient, but it might not be. It might be that you have very active xanthine oxidase levels because of fighting infections. And so you could produce a whole lot of uric acid. So the good news is that if you take molybdenum and your uric acid level shoots up really high, that means you are making MoCo, molybdenum cofactor. But if you aren't, I mean, if you, how do I say that? If you are making MoCo, but you're still struggling with sulfite metabolism, then you're probably not making sulfite oxidase. So how would you know? Well, one, you could get some type of urine strip to check for uric acid, or if you get a gouty toe, it's obvious. And then the second thing you could do is you could get a, a wine testing strip to check for sulfite in your urine. But if you have free sulfite in your urine, you're pretty far gone. And most of us are probably not suffering very badly like that. We probably have higher levels of S-sulfocystine and also destruction and kind of mopping up from all of the micronutrients in our body. So like our B12 is taking on sulfite, our B1 is taking on sulfite, that type of thing. So you could get a test by diagnostic laboratory solutions called OMX, and it checks blood for S-sulfocystine. So you have to choose the one that's both blood and urine so that you can get the S-sulfocystine marker. And that would be probably the best way to figure out if you're still struggling. It could be that you make sulfite oxidase, but you're just exceeding the capacity of the enzyme because of modern day lions. So, how would you deal with your gout? You could talk to your practitioner about these different things that can help inhibit xanthine oxidase. And I'm sure that there's good and bad things about each particular phytochemical over here. So, I'm not going to make any recommendations. So, if you are struggling still, let's say that you're having normal levels of uric acid, but you still have symptoms of sulfite toxicity, and you do the OMX test and you find out that your S-sulfocystine levels are high, then the presentation about MoCo synthesis is going to be really helpful for you, as well as how we assemble the sulfite oxidase enzyme. And that is definitely on my list of things to share with you all. And I have the slides ready. I just have to record the video. So thanks for being patient with me as I juggle my crazy life with my daughter and yeah, my own health, which is much better, by the way. I know some of you have been in the support group and from the very beginning, and you remember when I ended up in the emergency room, and I have not been to the emergency room since then. So, and I actually am doing pretty good most days. I have some bad days, and yeah, overall though, much better. So we have to work the problem and find the solution. I hope you are all doing well, and please check out the video about sulfite and thiosulfate altering oxalate metabolism and excretion. It changes it. Aren't you curious? It was a big deep dive. Have a great day.